Hello dear CMA aspirants from South India. As you all already know, Akash Agarwal Classes has launched for you all 100% English lectures in English for CMA Foundation students giving their examination in December 2025 and onwards. So here I am going to tell you how do you enroll in the batch. You just have to join our WhatsApp community which is given in the link. Fill up the Google form again given in the link and do download our mobile application Akash Agarwal Classes to access the notes. You all know the lectures which we are going to conduct will be 100% covered. There would be no subject which we are not taking care of. So we are going to take care of each and every subject, each and every concept. We are going to take MCQs for you. We are going to provide test papers. We are going to take live mentee sessions as well. Lectures which we are going to take for you all are 100% recorded lectures and not dubbed lectures. And you all know we have exclusive team ready for you all to teach you for your CMA Foundation December 2025 attempt for subject wise as well. And we are uploading the lectures on a weekly basis. All the important links which will be useful to you all are uploaded in the description box. Since we have many students who have cleared CMA examination at all the levels from Akash Agarwal Classes, and to reciprocate the love which we have received from South Indian students, we are here for you all taking lectures 100% in English, so that we can clear your CMA Foundation December 25 attempt together. So keep studying, do watch all the lectures till the end, and do show some love by liking the video, subscribing to the channel, and putting up a word in the comment box. Keep studying. Bye-bye.
Hello my dear students, so welcome back to another video, another lecture of our probability. So yes, first of all, if you are new to the lecture, you might be knowing, or if you don't know, that Akash Agarwal Classes, the number one coaching institute for CMA, the best result producing class, is here with the batch of English lectures. So we are conducting CMA Foundations lecture in 100% English. So yes, if you are new to the channel, what you have to do is you have to just subscribe to our channel. There's a link for WhatsApp community in the description. Do join that WhatsApp community for further more updates. We'll be coming up with more lectures of all these subjects, for maths, for economics, for management, for accounts, for all these subjects of CMA Foundation. So to get the links of that lectures and many more strategy lectures, what you have to do is you have to just subscribe to our YouTube channel and join our WhatsApp community. The link is available in the description. And do share this video with all your friends who also want the lectures in English, who are basically, they have a requirement for English lectures. So yes, don't forget to share this link. And apart from that, I have already started the probability chapter. The basic of probability has already been done. This is our second video. The first video was very short, and then we are going to continue with the next part. We started with the type 3, and that was combination. How are we going to use combination in our probabilities lecture? So if you have not watched the first lecture, I would suggest you to watch the lecture 1, so you get the clarity. By directly jumping to the lecture 2 won't help you. So you have to watch the lecture 1 to get the basic idea, basic clarity of the subject. Okay. So now let's start the combination form. Now we all know that combination is a part of permutation and combination, and there is formula for combination, that is NCR. And this NCR is further solved like n factorial upon r factorial into n minus r factorial. Yes, the formula is what? N factorial upon r factorial into n minus r factorial. Yeah, this is the formula, and now we'll be solving. I've already discussed the formula in the previous year in very detail, and I already explained what is factorial, how do we solve it, and what not and what else. Now let's go to the next question. Let's see the question. What is the question? The bag contains 6 red, 4 blue balls. We have already solved this question as well, but I am just revising it. 6 red, 4 blue balls. One ball is to be drawn. Find the probability that the ball is red. How many balls? Now we know what is the formula for probability. The formula for probability event A is what? Total outcomes in the denominator and favorable outcomes. So the formula is favorable outcome upon total outcomes. The formula is what? Favorable outcome upon total outcomes. Now over here I want how many total balls are there. There are 6 red balls and 4 blue balls. That means there are total 10 balls. And I have to select one ball. So now we know what is NCR. NCR is total number of items. And R is what? R is number of items that I want to select. So 10 factorial. Sorry, 10. C is what? C is selection. Right? And how much number of balls do I want to select? 1. So from total 10 balls, I'm going to select 1 ball. And now what is my requirement? My requirement is that the ball should be red. How many red balls are there? There are 6 red balls. So it is going to come what? 6C1. And now after solving 6C1, I've given you a short trick. If not, I'll tell you. See, if it is 6C1, what we are going to do, we will just go one step behind. So this is going to be 6 factorial upon 6 minus 1, right? 6 minus 1, that is 5 factorial. This is going to be 5 factorial into 1 factorial according to our formula. So 6 factorial is 6 into 5 factorial upon 1 factorial is 1. This is 5 factorial. This will go. So this is going to be only 6. Okay, I went through formula. Now what is going to be the short trick over here? One step behind. See, this is 6, this is 1. The number we see in the bottom, that many steps we have to go behind. So this is going to be 1 step, and then I'll be dividing by the number below, that is 1 factorial. So 6 factorial upon 1 factorial is 6. If I solve 6C2, 2 steps behind, that is 6 into 5 upon 2 factorial. So 2 factorial is 2. 6 into 5 is 30. And 30 upon 2 is 15. So this answer is going to be 15. It is very easy. You might have already studied in the permutation chapter. So this is 6. Similarly, 10C1 becomes 10. So after solving 6 upon 10, you get 0.6. You get what? 0.6. So answer is going to be 0.6, option number A. So this is a very simple question for your permutation. This is a very simple question for your permutation. Let's see the next question. 2 cards are drawn at random. I want to select what? 2 cards. Okay. So the selection is of 2 cards. You have to remember that thing. So 2 cards are going to be drawn from a random pack of 52 cards. So we know that the total cards are 52. To be selected are 2 cards. Find the probability that they are diamond card. Now we know that how many diamond cards are there? Diamond cards are 13. So what is our formula? Formula is favorable outcome. What is your favorable outcome? Diamond cards. So total 13. How many cards are to be selected? 2 cards are to be selected. And what comes in denominator? Your total outcomes. So total outcomes are 52C2. So 13C2, as I have already given you the short trick. 13 into 12. 2 steps behind and divided by 2 factorial, which is 2. So 13 into 12 divided by 2 comes 78 upon, this is going to be 52 into 51 divided by 2. 52 into 51 divided by 2 is going to be 1326. 78 divided by 1326 is going to be 0.0588. Now let's see from the option. 1 divided by 17 is what? 0.0588. That means option number 1. 1 upon 17 is my answer. Because when I solve 2 upon 17, it becomes 0.11, which is not equal to 0.05. When I solve 2 divided by 13, it comes to 0.15, which is again not equals. So option number 8 is right over here. So hopefully the concept that I have explained is clear to you all. 13C2 upon 52C2. 13C2 is 78, 52C2 is 1326, and then the answer is 0.0588. Because I want diamond cards, so my favorable outcome is diamond. How many diamond cards? 13. So it is going to be 13C2. Total cards are 52, 52C2. So this is going to be my answer over here. Okay, next. A card is drawn at a random from a pack of 52 cards. A card. That means I'm going to select how many cards? One card out of 52 cards. That means my denominator is going to be 52C1, because from 52 I'm going to select how much? One card. Find the probability that the card is a court card. What do you mean by court card? I have already explained. Court card means it might be jack, it might be queen, it might be king, or even it might be ace. So in court cards, how many kings are there? 4 kings. How many queens are there? 4 queens. How many jacks are there? 4 jacks. How many aces are there? 4 aces. So total how many cards? 4, 8, 12 and 16. So 16 total cards, including what? Including king, queen and jack and ace. So there are 16 cards. So my favorable outcomes are 16 cards and I want 1 card out of it. So this is going to be 16 upon 52. Once I solve 16 upon 52, it becomes 0.3076. Now let's check it out of the question. 3 divided by 13 is 0.230. This goes 3 divided by 13. It is 0.2030. Again this goes. 1 divided by 13 is 0.70. Okay, there is some, this is gone. So I can see option A and option number B has been repeated. That's an misprint over here. Now let's see. Once I solve 16 divided by 2, 52 divided by 2 is going to be 52. Let's solve 52 divided by 4 becomes 13. So, and 16 divided by 4, it becomes 4. So my answer is going to be 4 divided by 13. This is going to be your option number B. Yeah, 4 divided by 13. Option number B is going to be my answer. 4 divided by 13 becomes 0.3076, right? So answer is going to be option number B, 4 divided by 13. As you can see, there is a repetition of the option. Option 3 upon 13 is wrong, 1 upon 13 is wrong, 4 upon 13 is to be right, because 4 4s are and 4 13s are is your 52. So this is example number 3. Hopefully you are developing that and understanding the types of question that are being asked. Okay, mark this type of question, and very important question, because this is your institute's favorite question. Institute tends to ask this kind of question. It is institute's favorite question. Okay. So what is the probability of getting 52 Sundays in a normal year? Now 53 Sundays. So sorry. In a normal year. Okay. So now everybody is going to answer with me. If I ask any kind of questions, you are supposed to say it loud. Okay. So how many days in a year? There are 365 days, sir. Okay. How many weeks in a year? We don't know it, sir. We are not aware how many weeks are there. Okay. So tell me, how many days in a week? How many days in a week? Monday, Tuesday, Wednesday, Thursday, Friday, Saturday and Sunday. There are 7 days in a week, sir. Right? Not wrong. It is very true. 7 days. So how many weeks? So we can calculate weeks is equals to 365 divided by 7, right? 365 divided by 7 comes to 52.14 something. But weeks cannot be in point. Weeks cannot be in point, right? Now I have written that there are 365 days a week. Sorry, 365 days a year, 7 days a week, and now I am calculating how many weeks there are there in a year. I found it to be 52.14. Now I want round of weeks. So what I can do is I'll do 52 weeks into 7 days. 52 weeks in a year and 7 days. So it becomes 364 days. If I take what? 52 weeks, as I have found 52.4, I want to find a round off number. So I am taking 52 weeks and there are 7 days in a week. So it becomes 364 days. So now there are 364 days and I can see in a year there are 365 days. If I take 52 weeks by 7, I get 364 days. And total there are 365 days. So there is 1 day extra. There is 1 day extra. 52 weeks means 52 Sundays. Am I right? There are 52 weeks. That means 52 Sundays are fixed because in a week there is going to be a Sunday. So 52 weeks, 52 Sundays are fixed. Now question is asking me, what are the probable chances that there are 53 Sundays in a year? So now I know that there are 365 days a week. By calculating, I found there are 364 days in 52 weeks. So there is 1 day extra. So that 1 day can be a Sunday. And what are the probable chances? How many at 1 day, right? I have only 1 day. What are my total outcomes? This particular one day can be what? This particular one day can be Monday, it can be Tuesday, it can be Wednesday, it can be Thursday, it can be Friday, it can be Saturday, or it can be Sunday. So this particular one day has 7 total outcomes. The one extra day might be anything out of the 7 total outcomes. So my denominator is 7. And what is my favorable outcome? My favorable outcome is only one, that is Sunday. So this particular one extra day, it to be Sunday, my probable chances are 1 upon 7. My probable chances are what? 1 upon 7. My probable chances of getting a Sunday, that one extra day to be Sunday, is 1 upon 7. Option number A. So hopefully the concept is clear over here. I would sum it up very shortly. There are total 365 days a week, and I know that. There are 365 days a year. I know that. There are 7 days a week. I know that. Now I'm going to find how many total weeks are there. So what I do is 365 divided by 7. I get something in point. So I want it to be a whole number. I want to find how many extra days because it is surpassing 52. So I multiply 52 into 7. I get 364 days. Now 52 weeks are making 364 days. But there are 365 days a year. So I find one extra day. Now one extra day should be a Sunday. So there are total 7 outcomes. These total 7 outcomes are what? Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. It can be anything from this. It can be what? Anything from this. The next question is going to be for 53 Sundays in a leap year. Now we are talking about leap year. So how many days in a leap year? Days in a leap year. So there are 366 days. Now we all know there is 1 day extra. Days in a week. Seven days. So 366 divided by 7 is going to be again 52 point something, 52.28. Now again I will solve 52 into 7. is going to be 364 days. So now I have 366 days in a year and 364 days after 52 weeks. That means I have extra 2 days now. I have how many days now extra? 2 days. Now what is the probability of getting Sunday? How many Sundays? 53 Sundays. What is the probability now to get 53 Sundays? 52 Sundays are fixed because I have 52. What? I have 52 weeks. That means 52 Sundays fixed. Now I want 53 Sundays. For 53 Sundays, what am I going to do? Total outcomes. How many total outcomes? I'll tell you total outcomes. The sample space now is going to be, if one day is Monday, I have extra 2 days, right? I have how many extra days? 2 days. So what is the probability? Out of this 2 days, if one is Monday, one day Monday, so next day is going to be Tuesday. If first day is Tuesday, the second is going to be Wednesday. If the first is Wednesday, the next is going to be Thursday. If it is Thursday, Friday. Friday, Saturday. Saturday, Sunday. Sunday, Monday. Just give me a minute. Hello. So the total outcomes are Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, and Sunday, Monday. That is total 7 outcomes. Now, what do I want? I want 1 extra Sundays. So, it might be Sunday, Monday, or it might be Saturday, Sunday. In both the cases, I am getting a Sunday extra. So, I have total favorable outcomes 2. So, my answer becomes what? 2 upon 7. Option number B. So, if it is a leap year, your answer is going to be 2 upon 7 for 53 Sundays. If it is a normal year, for 53 Sundays, it is going to be 1 upon 7. For leap year, 2 upon 7. For normal year, 1 upon 7. Because in leap year, I have 2 days extra, so 2 upon 7. I have 1 day extra, so 1 upon 7. That is as simple as that. Mark this both question, very important question, because this is your one of the favorite question of your institute, which is asked many times. Okay, let's go to the next example. Tickets are numbered from 1 to 100. They are well shuffled. So there are total 100 numbers. So the denominator becomes what? 100. They are well shuffled, and a ticket is drawn at a random. So I have to select one ticket from 100. So it is going to be 100 C1. And what the ticket has number which is a square. So let me make it. Let me first explain you the question. Total there are 100 tickets. First ticket is mentioned by 1, then 2, then 3. So there are 100 tickets, numbered 100, numbered till 1 to 100. I want to select a ticket which is going to be a square. So what all numbers? Like 1 square is going to be 1. So this ticket would work for me. 2 square is going to be 4, right? 3 square is going to be 9, then 16, then 25, then 36, then 49, then 64, 81, and 100. So these are what? These are your perfect squares. How many numbers? 2, 4, 6, 8, and 10. So these are the perfect square. These are my favorable outcomes. So 10 favorable outcomes. From these 10 favorable outcomes, I need to select one outcome. So 10 C1 is 10. 100 C1 is 100, which is going to be 1 upon 10. Option number B is going to be your answer. 1 upon 10. Very simple. The problem in this question is only understanding the question. If you don't understand the question, it is going to be difficult for you. So understanding is moreover important. Find the probability that the 4-digit number comprising of digit 2, 5, 6 and 7 would be divisible by 4. So this kind of question is going to take a bit more time, because you'll have to apply some brains over here. It is not going to be possible without applying some brains. Some brains you have to apply. Probability is a 4-digit number. 4-digit number. Okay. 1, 2, 3, and 4. The number is going to be made by 2, 5, 6, and 7. And the number should be what? Divisible by 4. Should be divisible by. So first of all, like what is your total outcomes? Total outcome is going to be my 4 numbers and 4 digits. So this is going to be 4 factorial. My denominator is going to be 4 factorial, right? So again, to understand this question, you should have a basic idea about permutation. So this is going to be 4 factorial. So because I want to select, see, there are total 4 outcomes, right? 4 outcomes and all 4 are to be selected. So 4C4 becomes 4 factorial. 4C4 becomes what? 4 factorial. Okay, because I have to select all of the numbers. So my answer is going to be 4 factorial, and 4 factorial is 24. Now I have to select what? I have to find the probability that the number should be divisible by 4. Now, if you see 4 stable, in 4 stable, if you see the numbers 4, 8, 12, 16, 20, 24. The main thing, if you want the number to be divisible by 4, the last 2 digits of your number should be divisible by 4. Like, if I want any number which should be divisible by 2, what am I going to see? I am going to see that the last digit of the 4-digit number should be divisible by 2, or it should be even, or it should be 0, then it can be divided by 2. If I want the whole 4-digit number to be divisible by 5, I want that my last digit should be divisible by 5, or it should be 0. Right? Then and only then I can solve. But for in case of 4, your last 2 digits should be divisible by 4. So if you see 2, 5, 6 and 7. So if I take 25 over here, it cannot be divisible. If I take 67 over here, it cannot be divisible by 4. If I take 27 over here, is it divisible by 4? 26 divided by 4. That is not divisible, because it is coming 60. If I take 62 divided by 4, is it divisible? No. So if I take 52 over here, 52 divided by 4, is it divisible? Yes. 52 is going to work for me. If I take 54 divided by 4, it is going to work or what? No. If I take 62 divided by 4, it is going to work? No. 72 divided by 4, is it going to work? Yes. So 52 and 72 is going to work for me. 74 is not divisible. Then 54 is not divisible. Only 52 and 72 is going to work. So there are how many chances? First I have to make how many chances over here. See. So 52 and 72. So what are the possible outcomes over here? 52 is going to be fixed over here. Then the other two numbers are going to be 2 factorial. So this is going to be 2 ways. And then if I make it 2, then again this is going to be 2 ways. So 2 ways for coming for ending with 72 and then 52. Let me check. 76 divided by 4. Even I have 56 can work. 56 divided by 4 will work. 76 divided by 4 is also going to work. So I have 4 total. 56, 76. Okay. So I am going to have over here total 4 what you can say cases. So 1, 2, 72. 72. 1, 2, 52. 1, 2, 76. 1, 2, 56. And now you have to see over here 2 factorial, 2 factorial, 2 factorial, 2. So this is going to be 2 ways, 2 ways, 2 ways, 2 ways. And this is going to be total 8 ways now. In total 8 ways, I can find what? I can find a number which is divisible by 4. And now this is going to be 8 divided by 24. And this is going to be 1 upon 3, option number A. So what I did over here first is, I saw that I want to make 4-digit number. So how many total 4-digit numbers can be made? 1, 2, 3, 4. 4 numbers, 4 digits. So this is going to be 4 factorial, which is 24. My total sample space become 24. Now I want a number which should be divisible by 4. Now I have already explained you that to be divisible by 4, last 2 digits should be divisible by 4. So now last 2 digits are 72, 52, 76 and 56. These are what? These are divisible by 4. These are what? These are divisible by 4. Now after this divisible by 4, 72 comes over here, 7 and 2 is gone, it remains only 56. So 56 comes over here, 2 factorial. Now when 52 goes, only 6 and 7 remains. So this is the way by which I get 8 numbers which are divisible by 4. So my favorable outcomes are 8, total outcomes are 24. So 8 ones are and 8 threes are becomes 24. So answer is 1 upon 3. As simple as that. The answer is 1 upon 3. So hopefully the concept over here is clear to all. Example number 4. Now let's go to example number 5. A committee of 7 members. A committee of 7 members is to be performed from a group comprising 8 gentlemen and 5 ladies. A committee is made to be made out of committee of 7 members. So 7 members are to be selected. Now this question is again a bit trickier question. Everybody is going to keep an eye on it. I have to select how many members? 7 members. Out of comprising 8 gentlemen. So there are 8 gents and there are 5 ladies. Okay. So I have to make a committee of 7. That means 7 people are to be selected from 8 gents and 5 ladies. So what I can do is I can select total 7 all gents, right, and none of the ladies, or I can select 5 ladies and 2 gents. There are multiple ways for making 7 committee of 7. What is the probability that the committee would comprise 2 ladies? I want what? I want a probability so that how many ladies are to be selected? 2 ladies are to be selected. What would be the comprise 2 ladies? Okay, so they have told fixed. So how many total people are there? 8 gents and 5 ladies. So there are 8 plus 5, 13. So my denominator becomes 13C7. Because from total 13 people, I need to select 7. From total 13 people, I need to select 7. Right? So it is 8 gents and 5 ladies. Now I want 5C2 because they have told me to select 2 ladies at least. So out of 5 ladies, I am going to select 2. Now total I need to select 7. From 7 I have already selected 2. Now from 8 I need to select only 5. So this becomes 8C5 into 5C2 upon 13C7. So what is 8C5 now? How do you solve 8C5? 5 steps behind. 8 into 7 into 6 into 5 into 4. And divide by 5 factorial, which is 120. So it becomes 56. Now 2 steps behind, 5 into 4 and divided by 2 factorial. 2 factorial is 2, so this becomes 10. 13C7, 7 steps behind. 13 into 12 into 11 into 10 into 9. 13 into 12 to 11 into 10 into 9 into 8 to 7. So 3, 3, 6 and 7. Upon what? Upon 7 factor. It is 5040. So 13 into 12 into 11 into 10, 29, 28, 27 divided by 50. That becomes 1716. 56 into 10 divided by 1716. Just give me a minute. 0326. Just let me check whether the answer is right. Right, okay. It is 0.3026. 56 into 10 divided by 1716. 0.326. So now let's come to the option and check. 131 divided by 429. 0.305 gone. 140 divided by 429. 0.326. Yeah, so option number B is right. 0.326. Option number B. So this is the way how I am going to solve this question. Let me explain it again. I have to select 7 members for a committee from total 8 gentlemen and 5 ladies. So how many total people? 8 gents and 5 ladies is total 13. So I have to select 7 people out of the 13. So it becomes 7. And now there is a condition given that the committee should have 2 ladies. So I'll select out 2 ladies out of 5 first. So this is going to be 5C2 for selecting 2 ladies. I have to select total 7. Out of 7, 2 ladies are selected. Now only I want 5 gents. So from 8 gents, I am going to select 5. So this is going to be 8C5, 5C2 and 8C5 upon 13C7. After solving, this becomes 0.326. So hopefully the concept over here is clear to everybody. So you can write it down. The next concept is again, see over here. This is for at least 2 ladies. Now same 7 members are to be selected from 8 gentlemen and 5 ladies. But the question, previous question was selecting 2 ladies. That means it was fixed that we had to select 2 ladies. Now over here there is at least 2 ladies. Now I can select 2 ladies or 3 or 4 or 5. So this is going to be an at least question. So how do we solve this? I make the denominator over here becomes same. How many total? 13C7. So this becomes for gents. This becomes for ladies. Now first over here I'm going to select total. How many gents are there? Total gents are 8 and ladies are 5, right? Okay, at least 2, right? So they are saying at least 2. So first I select 5C2, then I select 5C3, then I select 5C4, then I select 5C5. When I select 2 ladies, I have to select how many? 5 gents, because I want total 7 committee, people of 7. So 5 and 2, it is going to be 7. When I select 3 ladies, I will select 4 gents, because 3 and 4 is going to be 7 again. This is 4, this is going to be 8C3. This is 5, this is going to be 8C. So this is the way of selecting committee of 7. So 8C5. Now the denominator is fixed. What is my denominator? From 13, I have to select 7. Now this 8C5. How do we solve 8C5? 5 steps behind. 8, 7, 6, 5, 4, 3. This is 8 into 7 into 6 into 5 into 4. 8 into 7 into 6 into 5 into 4. Divided by 5 factorial 120. This is going to be 56 into 5 into 4 divided by 2. 10. Then 8C4 is 8 into 7 into 6 into 5 divided by 4 factorial. 24. This becomes 70. 74 into 3 divided by 6. This becomes 10. 56. 4 into 3 into 3 divided by 54. This becomes 8 into 7 divided by 2. This becomes 28. This becomes 120. 5 factorial is 120, right? Yeah. So now this is 560. This is 700. This is 280. Three 360. Oh, sorry. 5C5 is 1 because 5 steps behind. Divide by 5 factor. 5 into 4 into 3 into 2 into 1 upon 5 factorial. 5 minus 5 0 upon 5 factorial. So 5 factorial upon 5 factorial it becomes. So it becomes 1. So sorry, my bad. So this is 28. So when I am selecting 2 ladies and 8 gents, it is becoming 560 ways, then 700 ways, 280 ways, and then 28 ways. So there are total how many ways? 560 plus 700 plus 280 plus 28. 1568. Let me check. 560, 700, 280, 28, total 5. It becomes 560, 700, 28. Okay, so it is what? It is 1568. So my total outcomes are 1568. I can select committee. My favorable outcomes are how much? 1568. So my probability becomes favorable outcomes 1568. And total outcomes were 13C7. What was 13C7? I have already solved it earlier. 5040. So 1568 divided by 5040 becomes 0.311. 0.31111. Now let's solve over here. 392 divided by 429. 491 divided by 429. 140 divided by 429. 140 divided by 429. 0.326. Now yes, I need to solve, I guess, 13C7 again. C7, let me check this. Okay, 13C7 is 1516. 1516. 1716. So 1568. No, 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 no. And 716. 716. 0.9137. 392 divided by 429. 0.9137. So option number A is right. So this is the question of at least selecting two ladies. Now everybody is going to keep an eye. Everybody is going to focus. I am going to explain this question again altogether. See, what are we doing over here? First, we are. The question is, understand the question first. Question is saying we need to select 7 members. Okay. So I'll be selecting 7 members. So something C7 from a group of 8 gents and 5 ladies. So 8 gents and 5 ladies, there are total 13 people. So from 13 people, I am going to select 7 people. So 13C7 was my how much? 1716. This is my denominator. This is going to be useful in the last step. But now the question is the probability that the committee should comprise at least 2 ladies. So what is going to happen over here? It is said to be at least 2 ladies. So I can select 2 ladies. At least 2. Okay. So I can select 2 ladies. Yes. Can I select 3? Yes. Can I select 4? Yes. Can I select 5? Yes. So when I select 2 ladies, I have to select 5 gents. When I select 3 ladies, I have to select 4 gents. When I select 4 ladies, I select 3 gents. When I select 5 ladies, I select 2 gents. So this is going to be way of creating your committee. So for selecting 8 out of 5 gents, it is 56. For selecting 5 out of 2, it is 10. 8 out of 6, 10, 70, 10, 56, 5, 28, 1. So after solving, after adding this, I get there are total 1568 ways in which I can make a committee which might have at least 2 ladies, 2 ladies, 3 ladies, 4 ladies, 5 ladies. So there are total how many ways? 1568 ways for selecting at least 2 ladies. For selecting at least 2 ladies. So my favorable outcome is 1568 and total outcome is 1716. When I solve it, I get 0.9137, which is as option number A, because when I solve option number A, I also get 0.9137. So hopefully the concept is clear to everybody. Everybody is with me. They are able to solve the question. I am assuming it that everybody is with me and everybody is able to solve the question. Right? So let's go ahead. If anybody is yet to write, what you can do is you can stop the lecture there and there itself and then proceed. Now let's solve some. Okay. So this question is, I'll explain this question. This question is going to be your homework. For the following data are related to the distribution of the wages of the group of workers. Okay. So 50 to 60 range. This is the range. Wages ka range. So the wages from 50 to 60. There are total 15 people. There are total 15 people for wages between 50 to 60. Between 60 to 70, 23 people. Between 70 to 80, 36. 80 to 90, 42. So this is range given over here. Okay. For now, I'll remove this because the data over here is, I guess, incomplete. There is one number missing, or this is 12 and this is 5. Yeah, this is 12 and this is 5. Now let's go ahead. Let's see what the question is asking. If the worker is selected at a random, total how many workers are there? First we'll calculate total number of workers. So there are 15 plus 23 plus 36 plus 42 plus 17 plus 12 and plus 5, 150 workers. There are total 150 workers. Okay, and now we have to select a worker randomly. So my sample space is going to be what? 150 C1. That is 150 ways. Right? I am going to select 150 C1. One worker from total workers. So 150 C1, that is 150 ways. If the worker is selected at random from an entire group of workers, what is the probability? His wages would be less than 50. So wages to be less than 50. Wages starts from 50 to 60. There is no worker below 50. So there are total 0 people. So over here, for my first case, there are total 0 people. So 0 out of 50 is going, 0 out of 50 is going to be 0. Option number B. His wages would be less than 80. So wages should be what? Less than 80. So for wages to be less than 80, 15 is going to come, 23 is going to come, and 36 is going to come. Because all these workers, 15, 23 and 36 workers have salary less than 80. So my sample space favorable workers are 15 plus 23 plus 36 upon total workers are 150. So 15 plus 23 plus 36 divided by, this is 74 divided by 150. 74 divided by 150 is 0.493. 74 out of 74 divided by 150. 74 divided by 150, 0 divided by 150. So option number 2 is also done. Option number, point number 2 is also done. His wages would be more than 100. So wages should be more than 100. So to be more than 100, it is only 12 and 5. So option number C is 12 plus 5 divided by 150. 12 plus 5 is 17 divided by 150 is 0.1133. Option number C. His wages would be between 70 and 100. So wages should be between what? 70 and 100. So wages between 70 and 100 are 36, 42 and 70. 36, 42, 70 upon 150. $95 divided by 150. 0.6333. 95 divided by 150. So you can check the answers. 74 divided by 150, 17 divided by 150 and 95 divided by 150. So it is very easy. Only the important part is you understand the question. The understanding of the question is more important than solving over here. Then now let's go to the complementary events. Now we are going to go where? To the complementary events. I've already explained the complementary event. See now, if the probability of A is 1 upon 3, probability of happening is 1 upon 3. Then what is the probability of non-happening? That is probability of A dash. So probability of A dash is going to be 1 minus probability of A, because we know that the total probability is 1. So for finding probability of A dash, I have to minus it from probability of A. So my probability of A is 1 upon 3. So this is going to be 3 ones are 3 minus 1, 2 upon 3. So my probability of A dash is how much? 2 upon 3. So always remember, by subtracting happening from 1, we can find non-happening of an event. The probability of B dash. So probability of B is going to be 1 minus probability of B dash, as simple as that. So 1 minus 5 upon 7 is going to be 2 upon 7. Probability of B is 2 upon 7, option number B. Just subtract it from 1 and you get the answer. By just subtracting it from 1, we'll be getting what? We'll be getting the answer over here. Now let's go ahead. De Morgan's law. Okay, well, I guess I've already told you to write the De Morgan's law. Hopefully, I don't remember. No. So let's write the De Morgan's law then. Give a heading for De Morgan's law. Tell you what to write. De Morgan's law. What are the De Morgan's laws? First is probability of A dash union B dash is probability of A intersection B dash, which is equals to minus 1 minus probability of A intersection B. So if they are asking you intersection, probability of A intersection union B intersection, probability of A dash union B dash, I will find probability of A intersection B dash. How to find probability of A intersection B dash? By just subtracting 1 minus probability of A intersection B. Similarly, probability of A dash intersection B dash can be by union. A dash intersection B dash is probability of A union B dash, which is going to be minus 1 probability of A union. So these are the two formulas that you have to keep in mind. And now let's see over here the option number, example number 3 they have given. They have told you you have to find what? Probability of A union. So probability of A dash union B dash is what? Probability of A intersection B dash. And how to find this? 1 minus probability of A intersection B. So there will be intersection. So 1 minus 3 upon 7 is 5 upon 7. 4 upon 7. So my 4 upon 7 answer is option number A, 4 upon 7. Answer is what? Option number A, 4 upon 7. Similarly, over here as well, they are asking me probability of A dash intersection B dash. How am I going to get it? I will get it by probability A union B intersection. How is probability of A union B intersection? 1 minus probability of A union B. So 1 minus 5 upon 11. This is 6 upon 11. Option number C. So hopefully the De Morgan's law is also clear to everybody. Now let's see. One card is drawn at a random from a pack of 52 cards. How many cards are we drawing? One one card is drawn from a random out of 52 cards. So 52 C2 is going to be your denominator. Find the probability that the card is not spade. Very simple. Total cards 52. You have to select two cards from 52, right? And the card should not be spade. The card should not be spade. There are total 52 cards, and there are 13 spade cards. So from total 52, I will minus 13. So I'll get 39 cards. So from 39 cards, I have to select 2. So 39 into 38 divided by 2 is 741. And 52 into 51 divided by 2 is 1326. 741 divided by 1326 is 0.5588. So let's go. 1 divided by 4 is 0.25. It goes. 1 divided by 2 is 0.5. 8 is also going to go. 3 divided by 4 is 0. No. Okay. Find the probability that the card is not paid. Okay, so to solve this, if there is, okay, see. There's one error. See, when the question is for not a spade, that means the question is for your complement. That means your question is going to be for what? Complement. So when we are solving for I don't want spade. First, I will find spade card. So my denominator is 52C2 and I have to draw one card. That's the okay. First, I'll solve 52C1 and then I'll select spade card. So this is going to be 13 upon 52. And then I'll minus 13 upon 52 from minus 1. So this is going to be 52 minus 13, 39 upon 52. This is going to be 0.75. And this is option number C now. So always remember, when the question is for not a spade card, I will first find spade card, that is 13 upon 52, and then I'll subtract it from 1 so that I want what? Not getting a spade card. So it is going to be 39 upon 52. So I'll get what? 39 upon 52, option number C over here. Option number C over here. So hopefully the concept is clear. Like even if you don't solve, like what we can do is there are total 52 and then minus 13, then also I will be getting 39 only. And then I solve 39 upon 52, the answer is going to be same. But this is the way. If you solve the questions by this way, you won't be facing any problems or further questions. There won't be any hurdles for you. Odds in favor and odds against favor. Okay. So the last topic for the day we'll be discussing is odds in favor and odds against favor. Now, what is odds in favor of an event and odds against favor of an event? What do you mean by odds? First of all, make this thing very clear in your mind. Odds means chances. Odds means chances. So, what are the odds in favor of an event? What are the odds in favor of an event? So, what are the chances for clearing your exam? So, what is your favorable outcome? Your favorable outcome is to clear your exams. So, when I talk about odds in favor, I am talking about clearing your exams. And when I am talking about odds against, so I am talking about non-happening. The favorable outcome is clearing exams. But when I talk odds in favor, I talk about clearing. When I talk odds against, then I talk of failing your exams. So when my event, when I'm talking about a positive event, when I'm talking about the favorable event and happening of that favorable event, it is odd in favor. When I'm talking about non-happening of an event, it is unfavorable event or against the event. You have to keep that thing in your mind. So odds in favor of an event. Okay, the odds in favor of an event. So you have to keep this thing in mind. Okay, so odds in favor the formula is favorable upon unfavorable. Favorable upon unfavorable. In against the formula is unfavorable upon favorable. This is the formula. See, now I'll give you an example. Okay, I'll give an example for both. I roll a dice. If a dice is rolled, a single dice is rolled. What is the sample space? 1, 2, 3, 4, 5, 6. And my probability of getting a odd number or a probability of getting a probability event A find probability of getting a number bigger than 5. So I want a probability of getting a number bigger than 5. So what is going to be a probability? Favorable outcome. What is the favorable outcome? A number bigger than 5 is 5. Number bigger than 4 I'll do. Number bigger than 4 is what? 5 and 6. So my total favorable outcomes are 5 and 6, that is 2. And total outcomes are 6. So my answer is what? 1 upon 3. Right? My answer is what? 1 upon 3. My answer is what? 1 upon 3. This is my favorable outcome. What is my unfavorable outcome? My unfavorable outcome is going to be 1 minus probability of A. So 1 minus probability of A is 1 minus 1 upon 3, which is going to be 2 upon 3. So this is my unfavorable outcome. Okay. So keep an eye. Please understand this question. If I roll a dice, the probability, the sample space is 1, 2, 3, 4, 5, 6. I want the probability of number getting greater than 4. So number getting greater than 4 is 5 and 6. My probability is 1 upon 3. And non-happening of that event is 2 upon 3. Now, when I talk about odds in favor, my answer over here is going to be 1 upon 2. That means favorable outcome upon unfavorable outcome. When I talk about odds against, my answer is going to be 2 upon 1, unfavorable and favorable. So further, this 1 upon 2 is what? 1 upon 3 whole divided by 2 upon 3. First is favorable and the second is unfavorable. This is 2 upon 3 divided by 1 upon 3. Unfavorable and favorable. Favorable and unfavorable. So this is what? This is your, hopefully you have understood odds in favor and odds against favor. First I am going to find the probability of favorable and unfavorable item. And then I am going to mix it by odds in favor or odds against favor. So hopefully the concept over here is clear to everybody. Hopefully the concept over here is clear to everybody. Please let me know in the comment section if the things are clear. So this is the very simplest way to make you understand what is odds in favor and what are the odds against favor. I can also say over here probability of A upon probability of A dash, and over here we can say probability of A dash upon probability of A is what? Your odds against. So let's solve two examples for odds in favor and odds against favor. Then we will be done with today's lecture. So a card is drawn at a random from a pack of 52 cards. A card. So 52C1 is 52. Find odds in favor of getting a king card. So I want odds in favor of getting a king card. So first I need probability of getting a king card. So probability of getting a king card is, there are total 4 king cards. So 4C1 upon 52C1. That means 4 upon 52. This is probability of getting a king card. Now I want probability of not getting a king card. So probability of not getting a king card is 52 minus 4. 48 upon 52. So now the question is odds in favor. So odds in favor, it is probability of A upon probability of A dash. That is 4 upon 48, which is 1 upon 12. So option is 1:12. Option number A. For finding favorable, I need to find first what? Probability of A and probability of A dash. If it would have been odds against, if it is not odds in favor, it would have been odds against. So my answer would have become, rather than 1 upon 12, it would have become 12 upon 1. Simple. Now let's see one more question. The probability of the event A. The probability. See, they are asking me the probability of event A. So they are asking me probability of A. If the odds in favor are 3:2. So odds in favor is 3 upon 2. They are saying odds in favor. That means this is probability of A. And this is probability of A dash. And now they are asking me probability of A. So which is 3. This is 3 and this is 2. So this is going to be 3 upon 5. And this is going to be 2 upon 5. Right? So this is 3 upon 5. The probability is 3 upon 5. Option number B. As well as that. Because 3 parts of happening, 2 parts of non-happening. That means 3 upon total parts. 3 plus 2, 5. 2 parts of non-happening. 3 plus 2, 5. So this is probability of A. This is probability of A dash. They are asking me probability of the event. So answer is 3 upon 5. Option number B. So hopefully the part over here, the combination part and the probability in favor and probability against is clear to everybody. Right? So in the next lecture, we'll be continuing our part. Then we'll be seeing some theorem of probability. We'll see some examples and all. And hopefully in the next lecture, we'll be done with all the concepts. In the this is the second lecture. In the third lecture, we'll be done with all concepts, and then in the fourth lecture, we'll be starting with the MCQ part. Okay. So yeah, that's all from my side in the today's lecture. If you are new to the channel, do subscribe to our channel, because we have already started. All those are new. I've already told you in the beginning of the lecture. Let me tell you again. We have started a fresh and a new batch for CMA Foundation students. The lectures are going to be conducted 100% English. You don't have to miss the lectures at any cost, and do join our WhatsApp community. There's a link in the description box. Do join the WhatsApp community by clicking on that link. Okay, so yes, that's all from my side. Till then, see you in the next lecture. Keep studying. Bye bye.